All right, so we have another example where we're going to compare two populations. So they give us the race time in minutes for two cross country teams that are shown below. We're going to use the measures of center and variation for us to select the schools to which each of the statements apply. So they give us the race times for Smith Middle School and for Tri River. So the first thing is I set up the information so that it was in the form of a stem and leaf plot, since the first one was already set up that way. And when I set it up, I noticed for me, what I like to do is look at it like vertically. So I turn it this way and I notice that it does not look symmetrical, right? So if we look down here, we notice that it's not symmetrical. So because it's not symmetrical, what we did was we used the median for us to find our measure of center. So I'm going to abbreviate with S for Smith and T for Tri River. So our median is what we're going to use to find the measure of center. And so when I did that, remember, if you're looking for the median, you're looking for the number that is in the middle once you have organized all of your numbers from smallest to largest. By doing that, I found that my median for Smith was 10, and the median for Tri River was 10 as well. So next thing we need to do is figure out what the variation is going to be. And because we use the median, I want to also use the interquartile range for me to find the spread between or the difference from that center of Smith and the Tri River School. So when I did that, this is what my interquartile range looks like. And so remember, we just really care about the information inside of the box. So when I found the difference between the Smith school, it was 9.5 for our lowest point and 11.5 for the highest point. So finding the difference between there, it was 2. And then when I looked at Tri River, the interquartile range was 9 for the beginning of it, and it ended at 10.5. So that means that it was 1.5. All right, so what inferences or conclusions can we come up with based on the information that we found? So, number one, the median is 10. So, I'm going to turn on my camera here. Okay, so the median is 10. That was true for both Smith and Tri River. Okay. The data have greater variability. So they're saying the number is larger with that IQR. And so that was true for Smith. So we're going to put an X here on Smith. This team is likely to run the race faster. So remember, if you're running, you want to have the lower time. And so if we looked at all of the data that we had on here, our smallest number, so I just looked at our stem and leaf plot. And the school that had the lowest number overall, so this was like the lowest numbers. Um, this is the max numbers, and then this was our inner quartile range. So looking at that information, or if you were looking at the stem and leaf plot, you would notice that Tri River has the lower speed, or the fastest speed, sorry. And then the mean race time. So if you use the mean, you could definitely do that. And if you did, you would find that that applied to Tri River. So there's your answers there. Um, so let me just go back and highlight all those answer choices one more time. So we had Smith, Tri River. This was Smith. This is Tri River. And this is also Tri River.